we have this saying, humans have been prosecuting warfare by putting a metal in the air and into each other for 20,000 years now. You go back to the ancient Phoenicians or Egyptians shooting arrows at each other. Like, let's get away from that. Let's get metal out of the air to solve problems if we can. And that's the beauty of directed energy and this new nature of warfare. Exactly.
Am I gonna have to get a bow to fight someone if they have your system? It's the only way they fire back, right?
Exactly.
So all the electronic stuff will break.
They're going to be. We say that all the time. Our goal is to reduce the adversary to the dark ages.
Bo, thanks for being on the show today.
Yeah, thanks for having me, Joe. A pleasure to be here.
So, Bo Marr, you're the co-founder and chief technology officer of Epirus, a defense company. Epirus is, I guess it was the name of the bow of Theseus.
Yeah. It's a cool story that the company got started. There's Theseus was the hero founder of Athens, and he was defending Athens against the Persians with the Epirus bow that had an infinite quiver of arrows.
Yeah, infinite quiver of arrows, and you guys we're doing EMP technology, electromagnetic pulse technology, which means I guess you could have infinite arrows you can fire out of those things.
Exactly. We have created the world's first software-defined electromagnetic pulse capability, and so that's the beauty of it. Yeah, you get infinite ammo essentially.
So tell us a little bit about yourself and your background. What led you to co-found Epirus?
Yeah, so just a little bit about me. I was always big into circuits and software and technologies. Got my PhD at Georgia Tech.
And you were a D1 athlete at Duke. So you were a D1 athlete who was into circuits.
Yeah, a rare combination probably there. Yeah, I kind of found a commonality though. Like, you got to bulldog circuits. Like, you have to really. It's hardware's more difficult sometimes, so you have to really kind of be a persistent. And the same thing with football. To make a D1 football team, you just got to grind. You got to work hard. So I found a lot of similarities actually between football and deep technology.
And what were you doing with circuits before you were doing Epirus?
Yeah, so at Georgia Tech we were building silicon neurons. So the thesis was we worked on the DARPA Synapse program, where the idea is if you build neurons out of silicon that work much more like the brain, you can operate much more efficiently than like what you can on a GPU. So then from there, went to IBM, worked on Watson. So I was on the chip team that built the chips for Watson. That was just a great experience. Ended up there, and then I've always thought, and I think very similar to some of your thoughts, Joe, that I share, like this strong passion for defense. So I wanted to help out, and so I went to Raytheon to work in the aerospace and defense.
So it's important to you that America is strong. You believe in defending America, and a lot of people attack what our DoD does. Like overall, you're optimistic it's better for the world if America is stronger.
Yeah, super optimistic, Joe. I think this saying I like to use is like, I remember I read this article once in the Wall Street Journal that was like, hey, all of our PhDs are going to help people click ads more, which is great. That serves a really important part of the economy. But like, let's get some of our PhDs and some of our best engineers working on really hard problems too, like in the defense industry. And what a lot of people don't realize is the history of Silicon Valley really started with defense, right? Like Bill Packard from HP, like he was the Secretary of Defense. The internet, like self-driving cars, a lot of that technology started in the defense industry. So I think it's so important.
A lot of the original money into Hewlett Packard in the late 30s and early 40s, of course, was for World War II, and I guess a lot of big hires in the Valley early were all the big defense contractors. That's right, and then they kind of helped, and it seemed like it dropped out. It seemed like maybe starting in like the 80s, 90s, Silicon Valley started focusing on other things, and then this generation seems to be pretty against working in defense. As you're building a defense company, there are a lot of people who are attacking you for that, or who are not interested because it's defense, or what's the energy?
Yeah, we've had a surprisingly positive response to what we're doing, and I think that was one of the goals of starting Epirus with you, Joe, is that we wanted to bring that youth back into the aerospace and defense industry. And that was one of the really important founding missions of Epirus, because I saw it at Raytheon, right, is like the number of where I was just before we founded Epirus was like, it was so hard to get millennials and some of the younger younger kids. And I think that's why it's so important. Like a lot of the kids coming out of college now, they're like, oh, a startup that does aerospace tech, like that's so cool. So I think that's one of the things I'm really optimistic about. I think by starting companies like Epirus, I think we're starting to pull the generation back into these really hard problems, space tech and defense tech and aerospace.
So we're talking about really hard problems. Epirus is doing electromagnetic pulse technology, and you created a new chip, which is we call it smart power, which is helping this thing fire better. How does that work?
Yeah. So what ended up happening is one of our first field demos, we showed off our electromagnetic pulse weapon. We're putting out a gigawatts of power. And the observers, our customers were like, oh my gosh, how did you do that? Like, that shouldn't be possible. That's too much power. That's too much thermal. You would burn out the chips, wouldn't you? And we're like, oh no, we invented this chip that we're calling a smart power that uses machine intelligence to manage the power.
So you have all this power flowing through this system, and you want it to all flow to hit at once in a way that's efficient, and so the chip's fast enough to kind of talk to all these different parts of the system and coordinate the power, or what's it doing?
Exactly, that's exactly right, Joe. So the analogy I like to use is I live in a Manhattan Beach, California, down in Los Angeles. My wife makes me water the garden, so it's like the analogy I like to use is like if you have an old school hose, you just turn it on, you walk back to the trees, you're wasting just tons of water as you walk back in between plant to plant. What if you had a machine learning algorithm and hardware that you could cut off the hose so there's no leakage whatsoever, and then right before you get to
right when you pointed at the right plant, right before you pointed at the right plant, it would start to come out. So
yes, this huge burst of water to just enough for the plant, and then turn off again right when the plant got enough water, and then do the same thing, charge up, and right when you get to the next plant, that surge of water.
So basically you only want the power to be on exactly when it needs to be on, and that way you could use it much more efficiently.
Exactly. And it turns out a lot more efficiently. We're getting 90%, 95% power efficiency improvements. And so that's one of the things we're really excited about is we've spun that off into its own platform. So we have a smart power platform.
So you could use this for theoretically data centers, for other, there's other things in defense you're using it for. What's something else in defense you could use it for that you could tell us?
Oh yeah, sure. So right now there are, let's say I want to put new capability on a ship or new capability on a tank or a striker vehicle. Well, it takes power. And a lot of times these systems are at their power limit. So what smart power is so we're actually working on a couple of projects right now, both with shipboard applications and what I'll call military vehicle applications, where there's two big efforts going on right now. Is number one, to electrify those things. So they're like electric, like you can imagine like a electric tank, right? Or a hybrid tank, right? And so managing all the power more efficiently in that vehicle. The other thing is, even for still diesel driven vehicles, all that energy gets generated in a generator, and then maybe you have a radar that's blasting at really high power, and then you've got a laser that's blasting at really high power. I
have lots of lasers on my vehicles.
Yeah, so it's managing and it's charging up and storing that energy and using machine intelligence to figure out exactly when that needs to fire.
So the radar systems themselves, if you give it power at exactly the right time, I'd imagine you can have a lot more powerful radars as well.
Exactly. So you can have more powerful radars. You can have more items on your vehicle, more systems. You could also the vehicle will last longer in the cases that it is a hybrid.
So this is probably useful for planes and ships and any vehicle.
Yeah, exactly. We're working on a project right now. We're actually going to speed up. The goal of the project is to speed up a ship, because if all of its gas or energy is going towards the radar, it can't go towards the motor.
Why hasn't this been done a long time ago? Would this have been a lot harder to do with chips 20 years ago? Yeah. So the big thing that we've discovered is the power line example. So like if I want to manage the power going through a power line right now, outside that powers all of our houses, there's this giant transformer that uses 20 kilovolt lines. Previously, there was no hardware to manage. You can't digitize a 20 kilovolt line. There's no hardware that goes high enough power. And so the same analogies on a vehicle, right? 600 volt is a common voltage that's flowing around a lot of these vehicles. 800 volt in some of the new Porsches electric that are coming out. And so
previously there was no hardware. It was all analog. I couldn't digitize it because that's too high of a voltage. So what we've invented is a gallium nitride chips and a silicon carbide chips, these new chips that can handle 1200 volts, 2000 volts. So we've digitized.
The gallium nitride is the stuff that's the emissive material, so that when the power hits it fires stuff, right? Is that different?
Yeah, so we're using a gallium nitride to build solid state transistors. So it's kind of like the same transistors in your cell phone. So the analogy is like your cell phone, it could handle maybe 2 volts, the transistors in your cell phone, whereas we're building transistors that can handle 1,000 volts. So this is new because we're able to digitize what.
Got it. So because analog. You can turn the power on and off so quickly, you can handle a lot higher voltage, basically, because you basically can use more power more efficiently.
Exactly. So now we can write software for much higher voltage applications where before you couldn't because it was all analog.
So there's only so much power. So if you're using the power more efficiently, you're using it really quickly with higher voltage. Basically, higher voltage lets you use more power in less time. Is that part of it?
Yeah, exactly. It's like now that we can digitize a power system, we can slice it up into like 10 nanosecond time slices. So you find all these opportunities to save power. If you can break something up into little tiny slices.
You should have to go back to high school here. We have the P equals IV. Most of our listeners probably don't know. So it's just very, very, very basic. So the way I think of it is the currents, like the amount. The amount of electrons flowing through, and the voltage is kind of like the speed at which they're flowing. It's the delta between it, but which creates the speed. And so because you have more accurate use of turning on and off power more accurately, you basically deal with higher voltage systems because you're using it more efficiently.
Exactly. And you hit the nail on the head, Joe. Like, and the higher voltage we go, the more efficient it gets, it turns out. And so we published
interesting. So much higher voltage lets you be much more precise in how you're using it.
Exactly. And so what's really exciting is we've published a peer-reviewed journal article in December 2020 on a law. We've discovered, we believe we've discovered a law that the power density of these transistors, it's doubling about every 18 months. We plotted all the data back to like the 1990s, and sure enough, it's very similar to Moore's law, where the chips, Moore's law says that chips are.
Is this going to be more dangerous? Are you going to kill yourself by touching these systems more easily if the voltage is that high?
No, that's the great part about digital systems. Because I can digitize it, I can switch it off in a nanosecond. So we actually have current controls in our system. So in our directed energy system, Leonidas, it's very, very safe for the operator because we have all these controls that it senses.
So what is Leonidas, and what's Leonidas named after?
Oh yeah, so we named Leonidas after the great story of the 300 at Thermopylae.
He was the Greek leader at Thermopylae.
He was the Greek leader at Thermopylae.
We kind of have a Western civilization Greek theme going on here.
Yeah, we sure do.
And so Leonidas, it's the one of the EMP systems you've built. So what does it do?
Yeah, so basically what it does is it creates an electromagnetic pulse that's in a very well-defined beam. So we can.
So this is like a cone of microwave radiation.
Exactly.
So and this microwave radiation, it doesn't hurt people.
Exactly. It's safe for people. It's very similar to.
But it gives you a headache, maybe, or not really.
It's very similar to the cell phone radiation, right? So we've put our system through. Safety is one of our top concerns. So we've passed.
You're a defense company, though. You're trying to fight things, but you also really care about safety.
Yeah, it's like safety for our war fighters. Keep them safe. Like that's the goal, really. Is like help keep our warfighters safe, get these things out to the people that are defending our security, and not just warfighters, right? I mean, we've all seen the news, like stadiums are getting, like the Major League Baseball games got delayed last year because of drones. Airports are getting delayed because of drones.
So drones, one of our big concerns when we were studying this earlier is you could put a bunch of bombs on thousands of little tiny drones and fly them to a stadium, and you could probably have a terrorist attack that way. But so drones are a threat, and I guess ISIS was using drones to attack us earlier in the Middle East. They weaponize drones and they come in on positions, and I heard we had to shoot like rockets at them and stuff to take them out.
Yeah, exactly, Joe. I mean, it's a really big problem.
And so this cone of radiation from Leonidas can shoot down a drone. How far away can it shoot it down from?
We have demonstrated beyond a visible range. Like a good story I'll tell you is when we did one of our first field tests, field demos, we had about 70 customers come, generals and so forth. It was a great event, and one of the biggest technical challenges we had to solve is we were taking down the drones so far away. I remember Lee, our CEO, he comes over to me and he wants to watch. I was like, hey, you're gonna have to use these binoculars to see the drone go down. It's gonna go down so far away. And he's like, oh man, I still can't see through the binoculars, so we got a telescope. So
you have a telescope to watch out.
Yeah, one of the biggest technical challenges we had to do a demo for our customers was we snaked out like the longest fiber optic cable we could possibly find and put a setup way out in the field and pipe the video back to, and then we pipe some video back through drones and so forth. So
that's cool. So Bo, can you describe a little bit more? What does Leonidas actually look like?
Sure. So Leonidas, it can fit on the back of the truck. We're building form factors for that. We're building form factors for the top of military vehicles, as well as like a trailer mounted version of it. And so it's basically a flat panel. It's almost like you can think about it like a flat screen TV, like a big flat screen a TV. That's what a phased array does in it. So it's like
you said phased array. What's a phased array?
So a phased array is instead of just one antenna element, like a satellite dish, we actually have hundreds, and in some cases thousands of smaller antenna elements.
And these are each emitting photons.
Exactly. And so that's part of what smart power does is aligns them all, and they charge up all at the same time, and then they spatially combine in the air to focus the beam. So they all fire all these.
So they all fire about the same time and in a coordinated way to focus the beam.
Exactly. And so, yeah, you can imagine essentially a big version of a flat screen TV on a back of a trailer or back of a truck that can create these very concentrated beams of energy.
That's awesome. So you're firing, and how is the microwave energy taking these things out? What's it doing?
Oh, so it's creating such a high electric field strength that the voltage is high enough in the air. So it's shooting photons technically. So we're shooting photons through the air, and then once the photons hit the drone, it's creating such a strong electromagnetic field that it's creating an over voltage scenario on the electronics itself.
So you're frying the electronics in the thing that you're shooting with these photons from a kilometer or however far away.
Exactly.
You're being careful not to say a distance. I assume maybe it's a secret.
Exactly. Yeah. We some of our customers are very want us to be very careful.
That's
about
fair.
Exactly
I think we could be sensitive about how far away we're shooting things, and this is destroying. This is destroying like the system there, the electronic system. Therefore, I assume you could use it against a car or a ship or basically anything that has electronics in it. Do cars have enough electronics in it that you can stop them with this?
Yeah, Joe, one thing we're really excited about is I remember when we were first starting the company, we were talking about, man, it sure would be nice to be able to stop Nefarious boats out in the water. So sure enough, we've got a great video. This was just even recently. I
haven't seen this yet.
Yeah, I'll have to send it to you. We have a boat motor. We bought a boat motor, running the boat motor in our chamber there, and so we've now got videos of zapping boat motors. We've got a bunch of data how well it works. It works great on vehicles as well. So it's really any electronics.
So if your high school rival has the girl you like out on the date like really far away, you could just zap it and make them look bad. Exactly. Maybe that wouldn't work though, because then they'd be stuck on the boat in the water together. So okay, well we'll rethink this. But if you drive by maybe in particular, if you drive by someone's office and do this, will the computers go out?
Yeah, absolutely. It works against any electronics.
That's awesome. And then, so you're firing these photons from far distance, you're taking out electronics, it doesn't hurt people. And I guess there's a lot more drones in warfare these days, so this is important. Could it work against missiles as well? I'd imagine if you fire it from far enough away, would a missile no longer be able to have its tracking systems to hit where it's supposed to hit?
Yeah, so Joe, we have not tried it against any electronics where it didn't work. So every piece of electronics we tried against, it has been successful. So we've taken out GPS, we've taken out guidance systems. So we are actively doing research to assess the effectiveness against things like rockets and
rockets. And I guess you'd launch this into space and do it against a satellite if you wanted to.
I think that's a valid application.
Anything.
Yeah, I mean any electronics that we've gone against so far, it works. So we're definitely looking into all sorts of applications.
And the innovation was this power chip and smart power did you have to hire a bunch of other people to build these systems? Like, how does one build an electronic warfare system? Who do you hire when you're trying to do that?
Yeah, it's a really great team. I'm really proud of the team. So it's really cross-functional. We've got mechanical folks and thermal analysis folks. We've got a ton of software, great software engineers on our team. That because what's really novel about our system too is it's a digital beam-formed system, which means it's a lot of matrix math, like very similar to
computer graphics stuff.
Computer graphics stuff, exactly.
Yeah.
So we can do a bunch of matrix math. We can to form where the beam goes, put nulls in the beam. We can control the power
when you
level.
say put nulls in the beam, there's like maybe you want to wipe out all the electronics in an area except for you want to not wipe out my phone if I'm standing there. You put a null right there.
Exactly. So we can put an energy null. We call it a dynamic blue force zone where the user can kind of mark out where they don't want to fire, and it can even be dynamic so that it again with a big emphasis on safety for the people that are using it. Yeah.
That's awesome. So you theoretically could have a big area where you fire and just only take out certain things, not other things.
Yeah, it's very precise. It's kind of the best of both worlds of like a very precise beam, like a laser, but then also if like a drone swarm is coming at you, you can widen the beam or sweep the beam very quickly to take out a large drone swarm. So it's kind of the best of both worlds. You get the precision and the ability to take out like a large area if you need to.
And when is this stuff going to be in the field being used in active, warfare scenarios?
Yeah, so we're currently working with the DoD, our DoD partners, to get it out in the field right now. So we're actually doing we're doing our third big field exercise this in a few weeks, and so that it's all happening kind of as we speak. Really, yeah, the team's out there right now.
Amazing. So stepping back a little bit, the U.S. spends over $700 billion on defense. A lot of us are not convinced it's spending it as efficiently as it could. A lot of that people call is partially a jobs program. It's partially big contractors. There's cronyism. You worked at Raytheon before. I'm curious. Like, how much did you see? Was there a lot of waste going on at the DoD overall, along with some really good stuff? Or like, are we spending money efficiently right now on defense?
Yeah, I think one of the big things we realized and why we wanted to start Epirus is the cost plus a fixed fee model. It is what a lot of the big DoD programs use. It has some disadvantages where...
So the DoD people, like the more they spend, the more the money they get to make, basically. It's probably a bad incentive.
Yeah, the incentive is not necessarily to go super fast and come way under budget is a good way to say it.
So you could think of a much better way to do something way cheaper, way better, and everyone says, Bo, if we did it this way, we'd lose a bunch of money because we would only get paid cost plus.
Yeah, so that's what we're kind of bringing to the table here is like say, hey, DoD, we're building this thing in a commercial business model. So we're investing our own money to get this thing built and sell it. We're going to sell it to you as a fixed price. And so
rather than be in the basement of Raytheon and trying to get them to do things more efficiently, they might not always have the incentive to do things more efficiently because of how they're paid. If you can do a commercial off-the-shelf model, you now have the incentive to do things much more efficiently, and everyone saves money overall. Is that the idea?
Yeah, exactly.
And so over the past decade, there's all these war games we've done against China, apparently inside the DoD, and apparently we keep losing these war games inside the DoD, which is pretty scary. What are your thoughts on what needs to happen for America to innovate and to be able to make sure that we can beat these adversaries?
Yeah, Joe, it's a really great question that we think about every single day. And I think one of the big reasons we're building Leonidas is it's not just this product family is not just an electromagnetic pulse system. It's not just directed energy. We're expanding into all areas of what's called the electromagnetic spectrum, because that is what is going to assert control in the future area of warfare. So think about right now when two planes if they're doing a dogfight against each other, maybe, when you watch Top Gun or some of the old movies, they're shooting machine guns at each other.
It's about getting behind them and firing at them.
Yeah.
This is not what matters anymore.
Now they use electromagnetic spectrum, really powerful radars to see people hundreds of miles away in some cases. And so whoever has the stronger radar, the strongest electromagnetic control over the spectrum, that's who wins.
When you're that far away, you just launch a missile or what?
Yeah, so that far away. So some of these radars can see hundreds of miles away. You launch a missile, and the missile uses radar and guidance technology.
When you just put when you put Leonidas on the fighter jet, and just the missile would get like what fried by the photons though, or how would that work?
Oh, so that's one possible scenario is using like an airborne EMP for defensive purposes, direct energy. That's absolutely a case, but also making it a multifunction so that a Leonidas turns into a radar, and so a reprogram again using the software.
So
definability
Leonidas could
of
be
it.
a much more powerful radar by using the power more efficiently.
Exactly, and so if we using this really powerful technology, just make a radar that goes much further.
Is this going to make so there's this balance historically between offense and defense in warfare? So a lot of people talk about, you used to have cities that were really dominant because you couldn't break into the walls, and then you had the invention of the cannon, and all of a sudden you had these big empires form because people could just go conquer a bunch of cities by knocking it down with a cannon. So that was a case where offensive warfare got to be stronger. For a long time, offensive warfare was better. Does the EMP system actually give an edge more to defensive warfare now? Is that a shift where we're going to be able to take out a lot of things defensively, or how do you think about that?
Yeah, I think absolutely. We think about Leonidas as it really creates what's like a force field. You can create a force field around a base or a defensive area. So I think it really does change the game. And
so if we're gonna start a city state in the future, you can help defend my city state with this, and it would make it so it's harder for people to come conquer it.
Absolutely,
that would be good for freedom. Okay,
yeah.
Good. We'll talk more about this offline. Okay. So just stepping back a little bit about the DoD spending $700 billion. Some of it clearly is not as efficient as it could be. A lot of us are worried about how our adversaries are innovating in ways we're not. You're behind now one of the most innovative technology companies in defense in our country by far, and you're bringing in all this talent. Like, what do we need to do in the DoD to make sure that new innovative companies can win? Are there things about procurement we need to fix? Is there things culturally we need to fix? Like, what do you see? I mean, I've been myself pleasantly surprised that a lot of generals are starting to realize that the legacy primes, the old big defense companies, they're not really performing as well as we need them to. It's because it's so obvious that even like all the generals are realizing it pretty clearly, or at least a lot of them are. So what do we need to shift now in terms of how the DoD works to make sure we can bring in good innovation?
Yeah, I think speeding up their procurement timelines, because I think what we're showing, companies like Epirus are showing, yeah, we can build a direct energy system in 9 months. And that's how long it took us to get to first a prototype from concept, 9 months. And so if the acquisition cycle is 3 years or something, that's a big mismatch with how fast we can develop technology. So I think getting the acquisition cycle to match how fast we can build these technologies is one of the keys.
And then it sounds like you think more off the shelf, less cost plus in terms of how they do things is important.
Yeah, I think so. I think that's a really, because like we talked about, it gives everyone the right incentive. It gives the company the incentive to deliver fast and wring costs out, and it also protects the taxpayer as well.
So in building Epirus, you're having to attract the best and brightest from the defense world, from different parts of the technology world. What's the culture like internally, and what are you trying to focus on there for the culture?
Yeah, I think it's really simple for us. We focus on people first, and it's really paid off for us. I have employees come up to me every single day almost and say, "Hey, Bo, this is the greatest company I've ever worked for." And a lot of it is a couple of things. We challenge our employees to work on the most cutting edge of technology, and so true engineers, really love that about it. And then, but also eliminating waste out of the process, because our customers don't want us to waste time. Taxpayers don't want us to waste their money, and engineers and operations folks and employees don't want their time wasted either. They want to be working on cool stuff.
When you were at other big defense companies, you saw more waste. And what did you see that you want to fix in Epirus?
Yeah, so like one piece of the waste, again, going back to this like cost plus model, if it takes a lot of work to like track all the costs, and they have a thing called earned value where you have these big spreadsheets, and so it's like somebody has to like huge teams of people have to keep track of these huge spreadsheets and time cards and everything you're doing. And
it sounds very Soviet.
It's like, it's not like in and of itself, that does not add value to our customer. And that's what we think about is like, how do we spend every minute of every day adding value to our customer and building great products for them? And so I think that comes out, and I think people really see that. And
it's a culture where people actually care about doing what's best for the country and best for the customer and the taxpayers.
Exactly.
That's awesome. One really interesting theme that seems to be emerging here in warfare and technology is you're actually taking more people out of the equation, and it's more about like the technology itself. There's, whether it's robots, whether it's unmanned systems, whether it's you actually it's kind of cool. You're not attacking people, you're attacking the systems, and you're making the systems more powerful to fight the other systems. Is this where warfare is going? It sounds like you're not going to have to hurt people, but you're still going to be able to help win wars.
Yeah, Joe, that's exactly right. And that's one of the core missions of Epirus is like, let's provide defense and security and these new capabilities without having to hurt people. That's exactly, and that's the beauty of directed energy, I think, is you can make a place completely safe. We say sanitize an area in a way that will not have to hurt any humans.
Yeah, if the Romans were to sanitize an area, and that everyone get messed up. But when you sanitize an area, you're not hurting anyone at all. You're sanitizing systems that can fight you and that can attack you, and you're getting rid of all of their ability.
Yeah, exactly. Like we have this saying: humans have been prosecuting warfare by putting a metal in the air and into each other for 20,000 years now. You go back to the ancient Phoenicians or Egyptians shooting arrows at each other. Like, let's get away from that. Let's get metal out of the air to solve problems if we can. And that's the beauty of directed energy and this new nature of warfare. Exactly.
Am I gonna have to get a bow to fight someone if they have your system? It's the only way they fire back, right?
Exactly.
So all the electronic stuff will break.
They're going to be. We say that all the time. Our goal is to reduce the adversary to the dark ages. Exactly.
Awesome. So we started American Optimist because there's a lot of cynicism in the world right now, and a lot of cynicism in our country about ourselves. But I think Epirus is just a really cool example because you're taking some of the best of Silicon Valley technology world, of the defense technology world, and you have the top EMP company in the world that can only really be created in America. And so I mean, how do you feel about America? Is this clearly the place you want to be working? Are there competitors to what you're doing around the world that are threatening you, or how far ahead are you right now?
There's really no competitors that we're aware of right now, Joe, that have digitized it the way we have. There are other people that have built EMP systems, but they're very analog in nature, using like vacuum tubes and so forth. And so, I mean, Joe, I feel really lucky every single day to be working at Epirus and have this opportunity to help America. I think we really are in a golden age area of venture capital where you're right. Only in America could we get venture capital to start an aerospace and defense company. So I just feel really lucky, and it's been an amazing ride so far.
Awesome. Well, it was an honor to help you guys get it going, and I'm amazed by what you've done, Bill. So.
Yeah, Joe, your contribution and helping co-found the company was amazing, and we really appreciate everything you've done.
Well, congrats on the progress. Thanks for being on the show.
Yeah, thank you, Joe.